Here's problem number 33 from section 9.1. In a previous exercise, we calculated both the power series associated with this sigma notation, 1 plus negative 1/2 times x minus 3 plus negative 1/2 squared, that's a negative, times x minus 3 squared plus negative 1 cubed times x minus 3 cubed plus dot dot dot. And we also said that this is equal to a particular power series representation, and if I remember correctly, it's 2 over x minus 1. Let me just double check that. It's 1 because the leading term here is 1, and then it's 1 minus negative 2 times x minus 3, double negative, there's that, multiply both sides by 2, and you get 2 over 2 plus x minus 3, which is 2 over x minus 1. Okay, so that power series is equal to that function on its interval of convergence, which is, I believe, 1 to 5, and is equivalent to that whole power series. Now the question is, what happens if we take the derivative of both, the antiderivative of both sides in this form, antiderivative from 0 to x of f of t dt? Well, let's write that out. 0 to x of 2 over t minus 1. From 0, and this is dt, and then from 0 to x of this expression, and this is all in parentheses, infinite, and we're doing this with respect to t. Oh, made a little mistake here. Everywhere that I have an x in that right-hand expression really should be a t. T, because we're doing the derivative with respect to t, and it says f of t dt. Now the other thing is, this side is a relatively easy antiderivative to make. It ends up being 2 natural log of absolute t minus 1 as evaluated from 0 to x, and if we plug in x, we get 2 times the natural log of absolute x minus 1 minus 2 natural log of negative 1, and a natural log of absolute negative 1 is a natural log of 1. This whole thing's 0. So on this side we get nothing but the natural log of absolute x minus 1. On the other side, we might be wise to use a u substitution. How about u is equal to t minus 3? And that's going to help us out a great deal, because that means we're going to be doing the integral of 1 plus 1/2 u plus negative 1/2 squared. That should be a negative in there. 1/2 squared u squared plus negative 1/2 cubed u cubed plus dot dot dot. And now see, du is equal to dt. So this is all du. When t is 0, our lower bound of integration is going to be negative 3, and when t is x, our upper bound of integration is going to be x minus 3. Alright, so let's go ahead and take the antiderivative of each of these. We're going to end up with u minus 1/4 u squared plus negative 1/2 squared times 1/3 u cubed plus negative 1/2 to the third 1/4 u to the 4th dot dot dot, and we're going to evaluate this from -3 to x minus 3. And we end up getting x minus 3 minus 1/4 x minus 3 squared plus -1/2 cubed times 1/3 x minus 3 cubed plus -1/2 cubed. Whoops, I'm gonna mix up there. This one's squared. Yep. This one's squared here. -1/2 cubed back over to here. 1/4 x minus 3 to the 4th plus dot dot dot. And then beyond that, we're going to have this whole thing evaluated at -3, or -3 minus 1/4 -3 to the squared, and we're just going to continue putting -3 in all of these terms, plus -1/2. It gets to be a real mess. 1/3 -3 cubed plus -1/2 cubed 1/4 times -3 to the 4th plus dot dot dot. And so we end up with these two series that end up making up that difference. Now this thing is a constant, but unfortunately it isn't a geometric series, so I can't find its value directly. But essentially that's what we get when we do that term by term integration of that particular form.